Welcome to StatLab StatCrunch videos. In this session, we will be covering how to construct a probability distribution table given a frequency distribution. We're going to be talking about discrete and continuous random variables as well. In this question here, a frequency distribution is shown below, and it tells me about how many households have 0 television, 1 television, 2 televisions, and 3 televisions. And they ask me to find and construct the probability distribution. Now, if I had to do this manually, what I would do is, first thing first, I would go ahead and add all the probabilities, which is going to be 28 plus 441 plus 727 plus 1400. And that will be 259. So my sum of my probabilities is 259. And if I have to find the probability of having 0 televisions, that would be 28 over 2596. And that is rounding off to 2 decimal places or 3 decimal places, 0.011. And that's what I have. Now, this is 0.011. Now, if I have to find the probability of having 1 television, that is going to be 441 over 2596, and that is 169, and when I round it off, it would be 170. And the same is the case when you have to find for 2 televisions, 727 over 2596. For 3 televisions, it is 1400 over 2596. Now, how do we do this using StatCrunch? Okay, I'm going to go ahead and open this in StatCrunch. You go to Stats, Calculators. You're going to go all the way down to Custom Calculator. Your values are in television and your weights are in household. And then you're going to go ahead and compute. And here is your calculator. And when you get your calculator here, this area here would give you the probabilities. So you're trying to find the probability when your x is 0. So what you're going to do here is you're going to simply change this to a 0 and change your less than sign to equal to sign. And bingo, your probability is right there. So now your probability is 0.0107. Rounding it off, this is what you get. If you want to find the probability of 1, you're going to do the exact same thing. Change the 0 to 1 and compute. Probability of 2, change it to 2 and compute. 0.280, 0.280. Probability of 3, compute. 0.539, 0.539. And then once you have your probabilities, you're going to go ahead and construct your probability histogram. And in this case, it is option C. The tail is to the left, so it's skewed left. All right. And now moving on to the next question. Use the probability distribution to find the probabilities in part A through 6. In this problem here, it gives me the probability of a household having 0 dogs, 1 dog, 2 dogs, 3, 4, and 5. So now I'm trying to find the probability of randomly selecting a household that has fewer than 2 dogs. Alright, fewer than 2 dogs is probability of having 1 dog and probability of having 0 dogs. So probability of having 1 or 0, so I'm simply going to go ahead and add them, 0.687 plus 0.199. And that gives me 0.886, probability of having less than 2 dogs. Now, if I want to find the probability of randomly selecting a household that has at least 1 dog, When they say at least one dog, I could have one dog, I could have two dogs, I could have three dogs, I could have four dogs, or I could have five dogs. Because they are mutually exclusive events. So now, let me go ahead and do this manually so you can see what's going on here. Oops, where's my calculator? Where's my homework? All right. So now I'm going to go ahead and add 1.99 plus 0.073 plus 0.023 plus 0.013 plus 0.005. What do I end up with? Oh, I messed up somewhere. I know where exactly I messed up. It is 0.199 plus 0.073 plus 0.023 plus 0.013 plus 0.005. 0.313 is going to be the probability of having at least one dog. Now the next one is finding the probability of having one and three dogs. So you could have one, two, in between one and three is you could have a one, you could have two, or you could have three. They're again mutually exclusive, so so what you're going to do is you're going to add probability of one dog, probability of two dogs, probability of three dogs. And that would be 0.199 plus 0.073 plus 0.023, and that would be 295. That's exactly what we have. 0.293. Okay, let me expand this one a little bit and move this over. My screen is kind of wobbly here. Uh-oh. Okay. So now if I had to do this using StatCrunch, how would I do that? So I'm going to click open StatCrunch. And here I have the dogs and the households, stats, calculators, custom. The values are dogs and the weights are in households, and I'm going to compute. And now let's go ahead and answer these questions. Probability of having fewer than two dogs is less than two dogs, and that would be, I'm simply going to change it to less than 2 and compute 0.886, and that's exactly what we have, 0.886, 0.886. Now probability of having at least one dog means greater than or equal to 1. So I'm going to go ahead and change that here, greater than or equal to 1, and compute 0.313. And now I'm trying to find the household between 1 and 3 dogs. So when I have to find between, I'm going to toggle between standard and between. So click on between, and you see you have your right here, you have your blocks right here. So in between 1 and 3, that would be 0.295. Bingo, you have your answer. Now moving on to the next problem. Here we have the probability distribution, and they want us to find the mean, variance, and the standard deviation of the probability. So you know how to find the mean. You simply multiply x times the probability, x times the probability, x times the probability, x times the probability, and add everything. But today we're going to go ahead and work it out in StatCrunch. So I'm going to go ahead and open this in StatCrunch. And again, I have my discrete variables and the probabilities, stats, calculators, custom calculator, x is my variable, probability of x is my weight, compute. And when you see that your mean here is 3.333, and that's exactly what it is here. And your standard deviation is 1.5, rounding off to one decimal place, that is 1.5. And remember, the square of your, it always tells this is your standard deviation, and the square of your standard deviation is your variance. So what you're going to do is 1.487, and you're simply going to go ahead and square it to give you 2.2. Okay, so the square of your standard deviation is your variance. Please keep that in mind. All right, the next question, most of you had doubts on this one. In a game of roulette, a player can play a $10 bet on the number 31 and have 1/38 probability of winning. If the metal ball lands on 31, the player gets $10 paid to play the game, and the player is awarded additional $350. Otherwise, the player is awarded nothing, and the casino takes the player's $10. What is the expected value of the game to the player? If you played 1,000 times, how much would you expect to lose? All right, in this problem, so if you place a bet of $10 and you win, you get $350. And if you don't win, you lose your $10. Probability of winning is 1/38. So probability of losing is simply 37/38. Okay? Oops, that is 38. All right, now let's go ahead and do this using STATCrunch. So what I'm going to do here is I'm going to open up my STATCrunch. Okay, I'm going to say the amount. I'm going to use this as the amount. And this is going to be my probability. P of X. Okay. So if I win, I get $350. If I lose $10. Probability of winning is 1/38. So what is that? 1/38, which is 0.0263. Okay, 0.0263. And 1 minus 0.0263 is probability of losing. So 0.9737, 0.9737. So let me go ahead and repeat myself here. If you win, you get $350. If you lose $10. Probability of winning is 1/38. And probability of losing is 1 minus that, which is 0.9797. Once we have that, I'm going to go to my calculators, custom. They ask me for the expected value. Remember, expected value is nothing but your mean, the amount, the probability in px, and compute. And when you see that, my expected value or the mean is 0.532. Rounding off to the nearest cent, so if I play one game, my probability of losing is 0.53. But how many games do I play? 0.53. My stylus here. Times, I play 1,000 games. So times 1,000. You know what? This is not working. Let me do it on the calculator. So probability is 0.53 times 1,000, and that gives me 530. So probability of losing, so the amount of money that I lose is 530, and that is one of your options in your correct answers. So I hope this helps, and see you in class.